The goals for this module are to learn about true and false values. Now, those are known as truthy and falsy in the JavaScript world. We'll talk about learning the logical operators that are also available, such as and, or, and not. And we'll take a look at this concept called short-circuiting. Let's get started. In JavaScript, any variable with a value, such as a string that has characters in it, a numeric that is non-zero, or a Boolean true, is considered true, and you can use it in an if statement like that. Any variable that is a Boolean false, null, undefined, not a number, or an empty string is considered false. So let's take a look at an example of how this truthy and falsy works. Let's take a look at this function called true-false sample. I have two variables, price and color. I've set price to 200 and color to red. Again, based on what we saw in the slides, since price is something other than 0, it's considered a true value. And color, since it has some values in the string, is also considered true. We can check that by, on line 22, we can say result equals price greater than 10. So obviously that evaluates to true, so result when it prints out will be true. We can also use, on line 26, if price is greater than 10, we can test the expression in an if statement. But we can also simply do this on line 31. If we just care whether or not price has something in it, we can just simply say if price. We don't need to say greater than 0 because, again, if it has a value in it, it's considered truthy. Same thing on line 36 here, if color. So again, we don't have to check to see if anything's in it, or we don't have to do if color.length. We can simply check if color. And if so, it will print out color has a value. So let's take a look first off at these. Let's go ahead and open this up in our default browser and take a look at the truthy values. So up here at the top we can see the first one is if price is greater than 10, that's true. And then we get the other console.logs that say price is greater than 10, price is greater than 0, and color has a value. Let's go back and take a look now at the false values. So now, as you can see on line 43, color equals null. So if I were then to take color and put that into the Boolean function, which actually says take this value and convert it to a Boolean. Now, you don't have to do this. I'm doing it because I'm not using an if statement. I'm just doing it so that we can print out the value in the console. But this will come out false. Color equals empty string is false. Line 51, color equals undefined, will also become false. If on line 55 you let value and you don't assign anything to value, that will also be a false value. If you end up doing some arithmetic and that comes out to be not a number, that will also become false. Again, we could just simply run this. And now we can see all of these values down below are now reporting false values. Let's take a look at some logical operators now. So we have the logical operator AND, which is a double ampersand. So an example would be price is greater than 10 and price is less than 1600. We have an OR, which is the two vertical pipes. So price greater than 10 or price is less than 1400. We also have the NOT operator, which is an exclamation point. So this will negate anything. So not and then price greater than 10. So if price was equal to 200, then this would come out to be a false. Let's take a look at our various logical operators in action. Let's take a look at this function, logical sample. On line 16, I let price equal to 200. On line 19, I say if price is greater than 10 and price is less than 1600. So as long as both sides of that AND are true, then the whole expression is true. So on the console.log, we'll print out that string. Now take a look at line 24. If price is greater than 10 and price is less than 200. Well, obviously both sides are not true since price is equal to 200. Thus, the whole statement is false. On line 32, if price is greater than 10 or price is less than 1600. So in this one, if at least one of the expressions is true on each side of the OR operator, then the whole expression is true. Take, for instance, line 37. If price is greater than 10, it is, or price is greater than 1600, it is not. However, because one of them succeeds, the whole expression is true. Then on line 42, if not price less than 10. So it evaluates, since the price less than 10 is within parentheses, that piece is evaluated, and then the not operation is applied. So is price less than 10? It isn't, it's 200, so the expression is false. We apply the not, it becomes true. Let's go ahead and open this up in our default browser. Let's click on the Logical Operators button, and we see the results just as I explained in the code. Let's now talk about short-circuiting. Now, short-circuiting is simply an optimization for logical expressions. What it allows JavaScript to do is to bypass subsequent expressions in AND or OR conditions based on truthy or falsy. So let's take a look. So here's an example where I have an isColorRed function, and this function, if I pass in a black, it's going to return a false. Then, as you can see, I'm calling in the same expression another function called isGreaterThan1400, and I'm passing in 1401. So that will actually return a true. We're doing an AND. Now, remember, an AND says both sides must equate to true. We know that the first one is not going to, right? So when we're using the AND operator, if both sides must return true, but the first one doesn't, well, why should it even run that second expression? And that's exactly what happens, and that is short-circuiting. Now, short-circuiting for the OR is different than the AND because when using the OR operator, only one expression needs to be true for the whole expression to be true. So if we take this example now where we say isColorRed and pass in red, that's true. Thus, it does not need to run the other side of the OR because right then the expression is now true, so the isGreaterThan1400 does not get run. So let's take a look at a demo here of short-circuiting. Here we can see the function short-circuit AND sample, so we're going to use the AND. Now look down on lines 23 through 26 and you see the function isColorRed. And you can see what we're doing. We're simply return value is equal to red. And I'm going to put a console.log in there because I want to show whenever it goes into this function. Then on lines 28 through 31, I've got the function isGreaterThan1400, again passing in the value, and we're checking to see if that value is greater than 1400. Again, I'm using console.log to show that we've gone into the function. Now go back to line 20. Result equals isColorRed, but passing in black, and, so we're using the AND operator here, is greater than 1400. So what does this mean? It means that since we're doing the AND, JavaScript is going to first evaluate the isColorRed black. It will come back false, so it never calls isGreaterThan1400. If we've done this correctly, and if JavaScript is evaluating this correctly, all we should see in the console is this message. Let's go ahead and open this in the default browser. Bring up our F12 tools, and we can see that, yes indeed, short-circuiting is taking effect here. Let's now go take a look at the short-circuiting using OR. As you remember, in OR, each expression is evaluated until one returns true. As soon as one returns true, none of the rest of the expressions are evaluated. Take a look at line 41. We call the isColorRed passing in red. Now, as we know, that will actually return a true. Thus, there's no reason for it to continue on and do the is greater than 1400. Take a look at line 47. We then switch these two around. We do the is greater than 1400, passing in 200, which, as you know, will now return a false. So it now needs to go to the other side of the or and now do the is color red to see if that one will then return a true. Let's go ahead and run this. And now we can see on the first example, it calls the is color red first. That one returns a true. It never goes into the is greater than 1400. On the second one, however, as you can see, it calls the greater than 1400. Since that returns a false, it must go to the other side of the or and test that expression so it goes into the is color red. And this is how the short circuiting for or works. We have one more thing to talk about when we're talking about all the different operators, and that's order of precedence. So which order things get evaluated in when you have a big, long, complicated expression. Well, obviously grouping first, so you can group things by using parentheses, then not, then multiplication, then division, then modulus, then addition, then subtraction. So all of these arithmetic ones happen in the order they occur, left to right. We then have less than or equal to, greater than or equal to, equal, not equal, strict not equal. We then have and, or, and then finally assignment. So there is an order to which things occur. So you can look this up on the internet. There's a lot of people that have put some really good examples out there, and it'd be a good way to test your knowledge. In this module, we learned about truthy and falsy. True is a Boolean true or any variable that has some sort of value, whereas false is false, null, undefined, not a number, and an empty string. Logical operators and, or, and not help you make complicated decisions, but remember short circuiting, because that's going to determine if one side of that expression runs. And if that side of the expression is a function, that may or may not run that function. Coming up in the next module, we're going to talk about exception handling. We'll talk about try-catch, and finally, I hope you'll join me for the next module. The goals for this module are to learn how to handle exceptions using the try-catch statements and the finally statement. We'll also talk about how to throw your own custom exception and how to determine the type of error that has just been thrown. Let's get started. Your basic design pattern for when running code that could fail is to wrap it inside of a try-catch block. So we put the code that could possibly fail inside of the try. Then, if something does fail, it jumps down to the code within the catch block. So an error object is created and it's passed to the catch block. Now the finally is code that runs every single time. This is optional. You may not need a finally block every single time. Let's take a look at a demo of a simple try-catch block and also add on a finally block. In this function, simple try-catch, we declare a variable called result. We're then going to do in a try block, result equals x divided by 10. Now this code will actually error. JavaScript creates an error object with a name and a message property and passes that to the catch block. Now you can do whatever you want to do within the catch block. I'm going to simply output the message to the console. Let's go ahead and run this, and we'll take a look at how this works. So there you can see the error message that JavaScript created for us. X is not defined. Now what you decide to do with that error is completely up to you. Some people might publish this back to a server. You may even log it locally if you want to, although you really need to get it back to a server at some point. That's completely up to you. But let's take a look at the finally. So here's another function called finally catch sample. We're going to do basically the same code. We're going to let result. In the try block, we're going to do result equals x divided by 10. Now I'm adding some additional console.log messages in here just to show you what will happen. So when an error occurs on line 40, line 41 or any other lines after the line where the error occurred will never run. We then dive into the catch block. That code runs, and then if you have a finally, that code will always run even if it goes through the try block normally or if it goes through the catch block. Let's go ahead and run this. And as you can see, an error will occur. We then go into the catch block. I also spit out that error message again, and then we're in the finally block. So when an error occurs, we go into the finally. However, if it succeeds, so now let's go ahead and declare X, so X is now defined, and now we'll see that we will also go into the finally block even on success. So we'll go ahead and run this, and now you can see an error won't occur. That was the console.log statement, but no catch block because everything went successfully, but the finally block still runs as normal. While JavaScript gives us an error object, a lot of times the messages are just a little bit too cryptic and maybe don't explain enough about where you are in your code to help you track down the error. If that's the case, you can throw your own custom error object, and you might want to do this quite a bit. What you do is create an object with at least two properties, message and name. Then you can fill in the name with whatever you want and the message with whatever you want. And the message could even be like what file you're in, what function you're in, what object you're in, and include other properties of the object even that you happen to be in. There's all sorts of things you can do with this custom error object. So let's take a look at throwing your own custom error object. It's a simple one, but we'll give you the idea of how to at least start this process. I have a function called throw_error. In this, I try to call the attempt division, and I do that in a try-catch block. If we take a look at attempt division, it's basically the same function we saw before. We let result, we try result equals x divided by 10, but inside of the catch block now, once we catch that error, instead of just grabbing the original error message, I'm going to throw my own custom message, because this way I'll be able to add on some additional information. So look at the throw, this object, where I've got a message and a name property. Now, in the message, we say, in the attempt division method, the following error occurred. And I still grab the original message. That's always good to have. But I've added on some additional information here to make it a little clearer about where I was when the error occurred. As far as the name, you can give it any name you want, but I would try to give it something that maybe is a little unique. I just use custom error here, but maybe you want to do custom attempt division error or something like that, something unique and something different than the JavaScript errors, which I'll show you in just a minute. But let's go ahead and run this. So let's throw our custom error, and there you see the error gets bubbled back up. We then display that error message, and I added on also the error type. So let's go ahead and go back here, and we can see right here, after I've displayed the error message that came back, I then display the error type, which is the error.name property. Now we saw reporting the error type by using the error.name. Well, let's take a look at the built-in errors that get thrown by JavaScript. There is a reference error, a range error, a type error, a URI error, a syntax error, and eval error. Now, eval error is for backwards compatibility only. It's not used anymore, but you may still see it in some older code. Let's take a look at determining the error type. In my sample here, I've created a function called handleError, to which I'm going to pass the error object generated by JavaScript. And then on line 73, I'm going to switch on that error.name property. Because JavaScript is consistent, it will always pass me the same error name for each of its built-in error objects. So you can see we have a case for reference error, for range error, for type error, for URI error, for syntax error, and for eval error. Now, if you have your own custom types, that would then fall into the default, or you could add additional case statements here as needed. Let's then go all the way back up here to the top, and we can take a look. So a reference error is what I showed you before. The reference error is when you have a variable that is not defined. A range error is because you did something that caused an error in a numeric value. So in this case, I'm trying to do a toPrecision, which is a built-in JavaScript function that tries to give you 200 significant digits. Well, that's not possible according to JavaScript, so a range error occurs. Type error happens because the result is a numeric, and we're trying to apply a toUpperCase to a numeric value. Again, that doesn't work. That's only for strings. URI error happens when somebody gives you maybe a URL and it has some invalid characters in it, and you try to maybe decode that URI, it will throw an error to you. Syntax error, this is the one that's usually used now instead of eval error. So if you're using the eval function, and in this case I forgot the missing single quote on the end of hello there, so when you're trying to do an eval and you get an error, you're going to get a syntax error. And then as you can see in each one of these catch blocks, I simply call the handle error. Now that's just this sample. You can do whatever you want again, but it's nice to know that you can check for the type of error and then decide what to do based on that error. So we can go ahead and run this just so you can see it. We can see a reference type and what its default message is. We can see a range error and what its message is. We can see result.toUpperCase is not a function. We can see that the URI is malformed. And we can see when we're doing the eval that an invalid or unexpected token occurred. And you'll get all sorts of different error messages with that syntax error. But these are an example of the built-in JavaScript error objects. In this module, we saw that we should always add a try-catch around dangerous code. So anything that could cause an error, let's wrap it in that try-catch. You don't always need a finally block, but if you do need it, it's there. And remember that it runs every single time based on we go through normally or if we go through the catch block. So that finally block will run. We can also throw custom errors to communicate any specific information. This is very handy to give you additional information that you may not get just from the normal JavaScript error object. Remember to always include a name and a message property. Also, you could change how you handle errors based on the type of error. So you saw how I was passing in that error object to a switch statement, and then inside of each case I could do a lot of different things based on the type of error. Coming up in the next module, how to determine data types. We'll talk about the type of operator and the instance of operator. I hope you'll join me for the next module.